Hi everyone, it's Matt here from the MattExzy YouTube channel. Today I thought I would do a brief video, if possible, on powering QRP projects. And the reason for that is that I've discovered that most of them call for 12 volts. 12 volts isn't all that easy to come by in a ready-made battery package. I've discovered the Arduino Nano boards as well. They need a steady 5 volts and they do not have voltage regulation. So we'll cover that, that's also important. And you'll probably notice a Christmas theme with these tins as well. That's because I picked them up after Christmas. They were on sale for 70 cents each. They had some chocolate inside them. The chocolate was terrible, but they make very good cases for our little QRP experiment here. So first cab off the rank is something I put together with an Arduino Nano board and a MattExzy QRP circuit, which I've featured before. This one's powered off 3 18650 cells. Their full charge voltage is 4.2 volts. And ordinarily at full charge, I don't know how well that voltmeter is showing up. At full charge at 4.2 volts, they will equal 12 volts. This pack's currently at 11.4 because I've been toying around with this one for a little bit. Inside, if I can get a good focus here, you'll see an Arduino Nano board tucked away up in there. That's the keying transistor and all that conglomeration as well. It's messy. I didn't make this one pretty because I can just put the lid on and you wouldn't know what's inside it otherwise. Now, because that board needs 12 volts and these batteries give out 12 volts, no, it needs 5 volts and these batteries give out 12 volts, you can get on eBay these little down converters that are ordinarily used in, I think, things like USB charging banks and car 12 volt sockets to charge phones and things off. So there's 12 volts coming from this battery pack going into this little board here. There's a USB plug here, and that USB plug, this cable is very long, it plugs into that little nano board and that gives it a clean 5 volts. These aren't the best brand of 18650 cells. They say, here we go, they say they have overcharge protection along with short circuit protection, but I can tell you right now, they don't. So if you're making a proper tidy one of these, go for a much better brand than what you can find cheaply. And staying with the Christmas theme, yes, Rudolph's nose lights up red there. This one is running off only 4 AA's, 4 nickel metal hydride AA's, but it's still getting 12 volts. So inside this one, you'll notice we have the Frogs QRP circuit here, one of the full-sized Arduino boards here, and the battery pack is down here with 4 AA's. But you might also notice a third circuit over here, which is a boost converter, and it is taking the 5 or so volts from these AA's. Because these are nickel metal hydride, they have a slightly lower fully charged voltage than alkaline. If these were alkalines, they would be giving just around 6 volts, I believe. So this boost circuit is taking that 5 volts and it's boosting it up to 12. And because this is a full-sized Arduino board, it has its own voltage regulation on, so it can be connected straight into parallel with the Frog circuit. And there's a little set screw on this variable resistor here that you can control the output voltage. I've currently got it set to around 13 volts, 13.5 volts. That's just so when the voltage sags a little from the batteries, all of this here will still be getting 12 volts. Another obvious option for powering electronic creations that need 12 volts are these little plugs here. And if you use those in conjunction with a USB power bank such as this, and this little device here shows the voltage draw coming out of your USB device and also the current draw. These little plugs here, which sold on eBay for like $2 each. They actually have a little voltage boost circuit inside them. So you can use any USB power source and output 12 volts. The only caveat being they are limited to outputting around 10 watts worth of power, because they're ordinarily used for things like LED lighting, LED fairy lights and things like that. But they are an option for low-powered QRP projects as well. So this next one I've been working on, and actually just got working the past few days, is a beacon based on a frog circuit, as well as an Arduino Nano module, that as it beeps out its Morse code message, it will display on a small LCD screen, a 16:2 screen, what that Morse code is in real time. So this one I had a little bit of trouble with. The 3-celled 18650 battery pack wouldn't fit. So I'm using 2 at the moment until I can get another booster circuit, which is on the way. I'm going to boost these up to 12 volts, but for the time being, these are only outputting around 8.5 volts. And once again, there's the small USB converter, which is outputting 5 volts to the Arduino Nano module. So there we go. A few power options if you're fooling around with electronics in general. A lot of electronics kits you'll find from China and the like, not just QRP kits, they often require 12 volts. So there's a few ways to get 12 volts. As for this little thing, it's just using a modified Arduino program written by Mark Van Wettering, K6HX. His original code had what it was tapping out to serial. I just modified it to go to the LCD screen. But once again, I'll post that below if you would like to get some ideas on making this yourself. Cheers.